Okay, so now, um, and this is the second time I'm recording this because during the first time, I got an error because I ran out of hard drive space. So I had to go and delete one game so I could continue rendering this project here while I was doing another one. Okay, which again is 1 terabyte of space, so I was trying to figure out before, and that's nothing compared to the videos that I have to store and stuff like that. Plus, I have a backup drive for 100 and some terabytes of space. Okay, that has to be upgraded as well. Okay, and my data right now is stored on this 4 terabyte hard drive, which obviously is enough for my stuff. But nonetheless, I want to talk about virtualization. Okay, now, okay, virtualization is the concept, all right, of taking this PC, which might have 64 gigs of RAM, 4 terabytes hard drive space, uh, 6 cores, right? And I'm going to take this particular PC, which one operating system, which is called Windows, is using all these resources as those resources are needed. Now, within this Windows, I'm going to run VMware, okay, and set up multiple versions of me having a separate PC, okay, within the umbrella of Windows. Okay, so here's my third, and my fourth PC. Okay, are each borrowing a little bit of these resources, okay, to make ourselves little mini machines. Okay, which is what I'm calling them. Doesn't mean which you want to call them. Don't care now because it's not relevant. Okay, now you gotta understand, in order for this VMware to work, means it must have a underlying PC or hardware to borrow those resources from. Okay, now that is what we're going to call the underlay. And we're going to use this term a lot in networking. So just understand what I'm saying. The underlay is my physical hardware, okay? And with the physical hardware, I am going to put on or install on that physical hardware a operating system, okay? And now that operating system, which is Windows, okay, is software that is used to tell the hardware what to do. Alright? Now, VMware comes around as a software, okay? And its job is to borrow resources from the underlay hardware that I have Windows sitting on, okay, to create other Windows machines. This is great. And now here's the thing, okay? This virtual machine, okay, I can communicate with each other, okay? I can communicate with each other via a virtual NIC card, okay? And even share the network card, the physical one here, okay, that is connected to the internet to give each one of these PCs internet connectivity. Now, here's the thing. We might work in a virtual world, but that virtual world can only exist with the underlay. Okay? And all this virtual networking stuff like that, that's not what you and I do as a network engineer. Okay? Now, it can from some aspects of your job, but we deal with physical stuff. Okay? Alright? Now, CSR routers, they're virtual. Okay? And have to admit, it is the only virtual devices that I use and love them to death. because those bad boys are phenomenal. Okay, and they're sturdy and they're reliable. I love them. Okay, all right. And now the fact now that I have my RAM, I'm going to start playing with those after this video to get some of those up and running as well. Now, okay, within the software of VMware, okay, the cool thing about it is I can have a virtual switch where my PC is connected to, okay, and I can separate these connections via a VLAN, we'll say VLAN 10, okay, and this PC is connected to VLAN 10 as well, and now that's the only thing that's in VLAN 10. So technically it's like these PCs are physically connected to each other, okay. That's how we manipulate our virtual aspects. Now, I'm not gonna lie, okay, I'm very adamant about this. Virtual VLANs is not the same as a physical VLAN on a physical switch, okay? Not the same, okay? All right, there's no ASIC emulation with this software or any other software out there that does virtualization. Can't do it, sorry, okay? And in the near future, if they could do it, I don't really care as long as it can do the job that I want it to do and it is trusted, okay? But right now, all right, I don't install virtual switches. I install physical switches. So I need to create that physical aspect as easy as much as possible, okay? All right, so that's what we're going to talk about. Let's do this. This will probably be a lot easier. So now, here, oops, VM. Where's my undo button? I'm looking for it because my keyboard is underneath the desk. So it's kind of drag. Actually, let's just get rid of this. This keyboard pad, so I can get to the keyboard a little bit. There we go. All right, so now, under my VMware, okay, I have PC1. Now, this has a virtual NIC card, okay. The data that goes out of this PC is a virtual NIC card. Now, what I want to do is take this virtual NIC, okay, and I want to bridge it to a physical. I'm sitting there trying to figure out how to spell physical. Hold on for a second. To a physical NIC card, okay, which is going to be my USB NIC, okay. Now, that bridge means that anything that goes out of PC1, only too, keep that in mind, because I can only make one bridge. I can't bridge two PCs to a network card. Now, again, don't challenge me because I'm gonna show you how to do it. I want in a video if I choose to. But in this instance, I'm not going to do that. Let's put it that way. I'm only going to bridge one virtual NIC to a physical network card, meaning that I got 4 USB network cards plugged in here into my PC, okay, and PC1 is bridged to NIC 1. Now with that, I got a cable that plugs into my physical Cisco switch. Okay? Alright, now on this port, I can put this port on a physical switch in VLAN 10. Okay? Now PC2 is going physically to NIC 2. And this is plugged in to VLAN 20. Okay? Now, however we get these two to communicate, what I want you to understand is I've taken this virtual down to a physical aspect, eliminating all aspects of this except the bridging of the of the virtual to the physical. Okay, there are times that you might have to delete this bridge, okay, and reconfigure it. All right, you know, you still have that layer of troubleshooting that's needed. So, but as long as this part is good, okay, I now have a virtual PC down to a physical aspect, meaning that I have eliminated the concept of traffic bleeding. Meaning that if there was a way that these virtual NICs communicated, that means even though they are physically in two different VLANs, PC1 can still be ping PC2. Okay, they're still on the same broadcast domain because this software is allowing it. But we want to eliminate that, and we want all our traffic to be separate as if they were separate physical machines. So this is how we turn the virtual into the physical. Now, okay. We have a PC sitting here, and we have on the other side of the house PC2. Okay, connected to two separate switches with 19.1.1. Actually, let's kind of make this uniform here. 19.1.1.1 on the same broadcast domain. Okay, on the same network. Now, this is in VLAN 10. This is in VLAN 10. This is in VLAN 10. And this is VLAN 10. Non-trunk. You do not have to have a trunk between switches. Okay? It's convenient to have them. Okay? But you don't have to. Now, so since I've configured the links between them on VLAN 10, that means only PCs that are in VLAN 10 are these two, and now I have a path for PC1 to communicate with PC2 on VLAN 10, and nobody else is on VLAN 10. Nothing. Now, if this was a trunk link, okay, meaning that this is a trunk, and I only have PC1 and 2 on those VLANs, it's the same thing. Okay? Just because I didn't configure as a trunk port before, it doesn't mean anything. The traffic will still allow to egress switch 2 and ingress switch 1. Now, what I have done here is I have set this up as if PC1 is directly connected to PC2. That's all I did. And I can draw this physical outlook just like this from a logical perspective. Okay? Now, that's cool because that gives me the ability, okay, to create these virtual point-to-points using VLANs by only putting two devices on that actual device. Where the hell is my eraser? Is that it? Oh, that's small. Those are colors. Where is the size? You know what? Just forget it. Okay? I'm using a pen, so it ain't a big deal. There's just a lot of scratching. Okay, so now A lot of tedious stretching. Okay, so I'm gonna leave that mess there because I don't know how to make it bigger yet, and I'm not trying to. Okay, so now if I scratch this out here, okay, and replace these PCs with the same IP address scheme, okay, and make them into. Okay, I want to change that. There we go. Um, that is not what I asked for because you took it off a pencil. All right, so pencil. All right, you know what? This is not. It's going to take me a while, so just bear with me. What is this? Fill eraser. Would be nice to change the size of the eraser. Which, you know what? We're going to do it this way now. All right, and we're going to. Is it sketch? I thought it was sketching tool. Draw? I don't think it's draw. See, that's the problem because I can't remember the name of the program. So let's actually go through here and see if we can find it. And actually, I think I saw it. Did I? No. So let's go here. And we're going to search. Same thing. And no. So let's go back to here. And all programs. I'm still getting used to Windows 2. That's it, isn't it? Screen marker. That is it. Okay. All right. So I forgot the name of the program. Same way. So now, what we have here is our router. Router 1. Going to switch 1. Okay. All right. And this is 1.1.1.1. Router 2. Going to switch 2. And this is 1.1.1.2. Okay. And I don't care if these are trunks, okay? But this is in VLAN 10. This is in VLAN 10. Only. Those are the only ones in VLAN 10. Meaning that the logical aspects is a point-to-point link to router 2. Now, this is physically not a point-to-point link from router 1 to router 2, but logically it is. Because if I run a protocol or any message going out here, okay, goes into VLAN 10 on the switch, okay, and comes out of the VLAN 10 on the switch on this end, egress to ingress, right? All right, and vice versa, I have two-way communication back and forth, meaning that even a routing protocol, okay, that builds a relationships in and creates routing tables based on those relationships believes it's a point-to-point link. Okay? Alright? That's the concept. Now, that's cool because we can end up doing this. Now see, that's a much better eraser. Okay? Now, we can end up doing this. On this switch, okay, and what I'm going to do here is I'm going, hey, you know what? That's cool. Nice. Okay. All right. I'm going to create all these oval routers. All right. And create these lines. Hey, I'm getting better. I'm level 2 now in this program. Level 2. All right. So now, so let's go in here. Router 2, router 3, router 4, router 5, router 6. Okay. Now, VLAN 10, VLAN 10, VLAN 20, VLAN 20, VLAN 30, VLAN 30. Okay, meaning that I have a point-to-point link for router 1 and 2, router 3 and 4, point-to-point, router 5 and point-to-point. Okay, but what I want you to understand is this is cool from a perspective of creating separation and point-to-point links without having the routers side by side. Okay, that's cool as hell. All right. Soon we're going to talk about my setup here and how I do things to get around things. All right, but from this perspective, that's great. But you got to understand something, and what I want to make sure that this is sent to your brain correctly. I only do this from a perspective when I have to, not for a means of fun. Meaning that every physical point-to-point link you make, you eliminate another layer on top of it or underneath it as an underlay or an overlay, because this layer 2 must fully function in order for your layer 3 from this perspective and this perspective for it to work. Meaning there's another layer of functionality that must function. So if I have the ability to say router 1 to router 2 directly connected with the physical cable, I don't care if it's a cross cable, okay, or a straight through, doesn't matter, okay, they're working. There's no other layer to worry about. There's the physical router, the physical network card of the router, the physical cable, and the other physical router and network card of the router. That's it. And that's what I want you to get your labs to. Okay? All of this stuff is cool, and it does give you a better understanding on how you can create virtual scenarios from the physical. And highly recommended in a work environment, network engineer scenario if it is needed, either as a patch or a solid configuration, because complexity in the workplace is abundant. All right, so sometimes we make things overcomplicated. Okay, sometimes we're not smart enough to actually think beyond the physical. Okay, but okay, when you introduce this concept right here, all right, when you introduce this, you are introducing an unnecessary layer of troubleshooting. Yes, in the end, it could make you a stronger individual of thinking of that working spot. But yet, if this scenario is not going to be for your destination, like saying a CCIE lab, for instance, if it's not going to be on your CCIE lab, why add it to your studying? Guys, please don't do this. It is unnecessary. Okay? All right? Yes, it's cool. All right? Yes, it explodes your ego. But it's unnecessary. So now, okay, so now, how do I clear the screen? Okay, let's just do it this way. Okay, so now, I can't erase those. That's cool. All right, so so how do I get rid of them? There has to be a clear screen here. La la la, and there she goes. Okay, so now, here is my house. Who cares about straight lines? Okay. And here is the front door, okay, that, you know, you walk into. All right. Now, over here is the TV. Okay, what is that? I guess my rendering is done. So why does that? I have no idea. Okay, but that is done. And what did I name it? No idea. I'll upload that later. All right, so what was I talking about? Oh, okay. And this is where my files, okay, files comes into, okay. Now, technically, that's not where it comes into. So let's go ahead and undo that. Okay, because over here is a bedroom. Okay, and over here is another bedroom, which technically is not really there because there is a hallway. All right, and then over here is the bedroom that I'm in. Okay, so now this internet connection comes here onto a box. Okay, and that is fed along the wall and through this wall. Boom. Okay, all right, now this is where the files router sits. Okay, now from this files router, I have ran a cable, okay, to go into a switch here. All right, and then over here where my desk is switch 2, and a cable runs along the wall, okay, to connect the switches. Now, this cable here, all right, remember this Files has a DHCP server on it, okay? So, what I do is, if I decide to set a router here, okay, all right, router 1, I am going to VLAN this, let's say VLAN 55, all right, VLAN 55, okay? All the way down, VLAN 55 to FA01, okay? And then FA02, which is going to connect back into the switch, okay, is going to be on VLAN 20. Okay, so I have isolated the VLAN 55 to looking like this. Files to router 1. Directly connected. Okay? That's how I've done that. And I've used VLAN configuration to carry that traffic over where only Files interface and router 1's interface is the only thing in that VLAN 55. And now, check this out. This interface here, okay, because remember we got another one going into switch, even though they're both going into the switch, okay, one is going into FAO, one is going to the same switch, which I drew that incorrectly. I'm sorry. Let's erase that. I'm just realizing that mistake. Okay. This actually goes here. Okay. All right. And this is going to be VLAN 20. And this is not VLAN 20. Okay. So more accurate. So even though both router interfaces from router 1 is going into the same switch, they are separate domains or broadcast domains because of the fact of the VLAN allocations of the switch ports. Okay, now this looks complicated from the aspect of is it necessary, but from my perspective, it is necessary because I do not, if I have the files router run to here, okay, into the switch, why have the cable all extra to come over to here? Now, from your perspective, this looks really short to you, but we're talking about one side of the room to the other side of the room, okay, and I can move that traffic via VLAN allocations instead of having larger physical cables and more of a mess, okay? Does that make sense? All right. So I don't mind doing that, and it serves a purpose, a a well a well purpose surface, a well purpose. Sorry. Okay, and I'm not kidding about that. So that kind of layer troubleshooting, it is necessary for me, and I wouldn't have it any other way. Now, let me show you what my last was like. As a matter of fact, you know what? I think I have a picture of it. Let me go find it. Uh, ba, 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 ba. That's not cool. Oh, there it is. Okay, that kind of ticks me off. Are you serious? You're not even working, yo. So let's try. So now I got Chrome. I'm gonna have to fix that. Fine. Let's search the store. I don't really care. Oh my lord! Oh lord! Did I close? No, there it is. Okay, so out of my way. Okay, so I guess we're not gonna look at that for now. I will fix that later, but I don't know why it's not working. So let's go back up to here. So in my house, and I gotta think about this. Okay. So here's my basement. Here's the second floor. How did I do this? I really don't remember. I'm gonna have to take a look at the diagram. But nonetheless, where was that? It was upstairs, wasn't it? I had upstairs, this was the files. Yes, that's where it was. That was connected to switch 1, switch 2. It was fibered on the between floors. Okay, all right. That came there. I had another switch over here. Okay. This is where my voice lab was at. Okay, and that was where my phone line was going. And and then my garage is where my rack sat. Okay, that's where my servers were, and my routers and some switches. Okay, so now what you see here, okay, is me having switch 3 out here. Okay, I had a router sitting here, router 1, and I wanted all internet traffic to go through my router. Before it became an ASA, I used a zone-based firewall. Okay? Allocating those interfaces in which part of the firewall it was going to be. Now, this is definitely a scenario where moving the files traffic from this port all the way through, okay, to this switch, over to this switch, okay, I'm sorry, moving the files traffic down to switch 2 to switch 3, okay, allowing that router, which is also connected to here and to here, as a point-to-point link from the files to the router, okay, so I can firewall that traffic and then going back in that same switch on a different VLAN to send that traffic to switch 2, switch 3, okay, alright, and this is where my PC's set, by the way, alright, so, and back up to switch 1, so the PC's up here as well, okay, all that traffic was, had to go through the actual firewall, okay, alright, so another scenario, okay, and you think about that, but God, Kyle, is that really, that's unnecessarily complicated, and no, it's not, okay, now, think about this, okay, my other setup was, okay, alright, Comcast, Juniper, okay, and this Juniper was a virtual Juniper that sat in an ESXi server, okay, alright, and I had to VLAN that traffic over it. Now keep in mind, this ESXi server was trunked to the switch, and inside the the ESXi server, I had to set this Juniper up in a isolated VLAN, okay, alright, that means that the trunk, okay, that means this was in VLAN 10. It had to go across the trunk into the ESXi server and then go to only the links or the hosts that were in VLAN 10. Okay, that was kind of complicated. All right, but I did not. My physical Juniper died, and the only thing I had was a virtual, and I was studying Juniper at the point, and it served the purpose. And the next thing you know, I used Juniper to secure all the actual traffic going throughout the entire network, throughout the entire house, in this fashion. Okay, another way of doing point-to-point links with VLAN traffic. Okay, so, all right, let's do this. Come on. Okay, so now. So now, you think of another scenario, okay? You are connected to switch 1, okay? You have this router 1, okay? And it is here, but this link here is a trunk. Now, if you don't know what I'm talking about, don't worry about it. Routing lessons are coming soon, and this will be one of the topics. So I'm not going to explain it in detail because we're going to do that eventually. So just understand that this is possible, okay? And you create logical sub-interfaces off this router that is using this interface F800. We call them sub-interfaces. Okay? Now, every sub-interface is a different VLAN. Okay? So that's cool. You don't have to have all these physical cables, just one physical cable, and the router will do the will take care of the sub-interfaces and manage it from that perspective. Now, PC1 and PC2, okay, is in VLAN 10 and VLAN 20, okay? All right, and then this interface and this interface will be configured for 20, and this will be configured for 10. Meaning that for 2 VLANs, or maybe even 10, I can have one physical connection, okay, going there. But what you're doing is adding, okay, another layer of troubleshooting if something goes wrong with this particular sub-interface configuration, okay? What I'm trying to tell you is this. When you are studying, all right, get rid of these unnecessary layers, okay? All right? Because even today, when I'm learning something, okay, all that stuff is gone. Meaning if I can connect router 1 to router 2, okay, without going through a switch, I'm going to do it. Okay, and 9 times out of 10, router 2 is going to be sitting underneath router 1 or vice versa, and it's just a simple cable that's not even going a foot between each other. Okay, maybe 6 inches from interface 1 to interface 1 or whatever. All right, so I'm not going to add a switch, okay, to my configuration and create sub-interfaces and VLANs and layer 3 layer 3 VLAN interfaces. I'm not gonna do all that crap, okay? Because it interferes with me trying to understand the concept of the technology. Because if something goes wrong, you're thinking it's the technology, and layer 2 is broken somewhere, okay? And now you got to spend your hours troubleshooting, taking away from the time you're studying. Now, okay, it's not like the CCIE lab is not going to use sub-interfaces, okay? But when I look at some people's curriculum and it's VLANs galore, okay, that's not something that you're ever going to see on a Cisco exam. Now, I can only tell you routing and switching from my perspective during the time frame that I've done the routing and switching, okay? But, okay, if if I walk into a lab, okay, I doubt Cisco is going to have all those layer 2 aspects of it because they have a layer 2 section to test you on. Why stick layer 2 on top of underneath layer 3? Okay, just from a design perspective, okay, to make you have to troubleshoot layer 2 when it shouldn't even been a factor. I just don't see them doing that. Okay, and when I go to take my security lab, okay, sure, I might have an ASA, okay, with, maybe 2 sub-interfaces, maybe, okay, but I'm not going to have the ASA to go into a switch, okay, with 10 sub-interfaces, all right? Now, I say that, okay, all right, but if you're under the situation where you're doing, like, VRFs, and you don't have enough physical interfaces on your device, yeah, I can see you using sub-interfaces from that perspective, right? But make sure that your layer 2 aspect, okay, is necessary for the lab and not from your personal unnecessary adding of layers that could break in order for you to do what needs to be done. Okay? That's all I'm saying. Now, that's my opinion. Do what you want. It is your lab. Okay? There is no right or wrong aspects unless you are doing it wrong and you just can't get your pings to transit from source to destination. Okay? Otherwise, I I don't care how you build it, as long as you're learning, as long as you're doing what you want to do. This video was really just a warning to someone that doesn't really know better. Okay, they might create these things out of a sense of thinking that it's a necessity and not really realizing the unnecessary aspects of it. Okay, so see you guys on the next one.